She just said that. Oh my goodness gracious.
So, notes 7.3 and 7.4 and 7.5 are the really algebraic pieces of this chapter. So we're not doing like the graphing parts as much. We're focusing on like how to rearrange, how to combine or separate, that type of thing. And so I just want to review on this slide really quickly. This whole chapter, chapter 7 itself is called like rational functions. So we're learning about rational functions. And these next two sections are going to talk about doing operations with rational expressions. So that means things that look like rational functions. And what is a rational function? Well, we've already talked about this in section 7.2. Rational functions or rational expression has the math word ratio in it. A ratio sometimes has that colon, but really it looks like a fraction. And if you have something that is a fraction, you can also think about it like it's a quotient, right? A numerator divided by a denominator. So all of these things are true about rational functions, rational expressions. Today we're going to simplify, multiply, and divide. Tomorrow we're going to add and subtract. And then on Wednesday we're going to do something called complex fractions, which is fractions inside of other fractions. Yes, I know, everybody's favorite. We'll quiz over those sections on Friday. And then next week we still have to do 7.5, which is like solving equations that have these fraction-looking things in them. Okay, so we're kind of building up to that. For today, really important to note, like always with a fraction, well, really in any math class and any chapter test, when you're writing answers down, don't you want your answers to be in simplest form? Whether it's a fraction or it's a radical, you always want it to be in simplest form. So we want our rational expressions to be in their simplest form. That would mean the numerator and denominator have no common factors. So if you're thinking, just about like third grade fractions, 6 over 8 is not in simplest form because 6 and 8 share a common factor of 2. I don't know if you'll ever remember writing like prime factorization of numbers, but it's just like what are the factors of 6 that are prime numbers? 2 times 3. What's the prime factorization of 8? 2 times 2 times 2. And so essentially what you're doing there is when you're reducing the fraction is you're saying you have a 2 in the numerator and a 2 in the denominator. So then your answer is 3 over 4. Now, of course, you don't do all that work every time writing out the prime factorization, but it's good to kind of review that. Like that's essentially what's happening there. That's why that works. Okay. So, of course, ours aren't going to be third grade fractions anymore. Ours are going to look like the things that we've seen in chapter 7 that have polynomials in the numerator and polynomials in the denominator. Okay, so we're going to start with simplifying. I don't know what I did on my smartboard to make all these things come up small. I apologize. Just zoom in here. Figure that out later. Okay, you should know how to simplify a rational expression. This would be a rational expression because it looks like a ratio. From Algebra 1. So not only can you reduce fractions from 3rd and 4th grade, but you can reduce fractions with variables in them from Algebra 1. You got 2x squared y all over 8x y to the 4th. Go ahead and just kind of have a quick conversation with your pods. Like, what would you do to simplify this ratio? Okay, So as I'm walking around and kind of listening to conversations, I hear a few things. Well, you have 2 8s, which you can reduce to be 1/4. Okay, and then you have these other powers that have the same base. So you have like x squared over x. If you're dividing powers with the same base, what can you do with your exponents? Subtract them. So there's more x's in the top, so we would do like 2 minus 1, and we'd end up with 1x in the top. And then for y's, we have y over y to the 4th. There's more y's in the denominator, so we could subtract the exponent 4 minus 1. We'd be left with y cubed in the denominator. Okay. Now, I am going to do this, but I'm going to do this the long way like I just did that 6/8. I'm going to write everything as like factors. Okay. So 2 is really like, I guess I could say 2 times 1. Okay. And then do you agree that x squared really means x times x? Yeah. And then we'll have times y. And then for 8, I already did that one with the 6/8, but that's 2 times 2 times 2, 2 cubed. And then we have 1x, and then we have y times y times y times y. So this is like why the properties of exponents work. You would have talked about this in Algebra 1, but we're just kind of like reviewing this now. So this is like the long way to do it if you don't know the shortcut of subtract your exponents. But now I can go through and I can cancel those common factors. So a 2 in the numerator cancels with a 2 in the denominator. The one of my x's in the numerator will cancel with my x in the denominator. And my y in the numerator will cancel any one of the y's in the denominator. Now I can't cancel anything else. So now I just have to like write whatever's left over. In the numerator I have x, and in the denominator I have 4y cubed. Isn't that what you would have gotten based on your properties of exponent shortcuts? Okay, so that's kind of like the long way to do it. And what I want to point out is in my long work, do you see all the things that I wrote out? Everything is being multiplied. So those things are factors, things that are getting multiplied, so I'm allowed to cancel common factors in the numerator and the denominator. Okay. So it's important that before you start canceling, you make sure you have factors. Here's what things will look like now that we're in Algebra 2. Something like x squared plus 5x plus 6 all over x cubed plus 2x squared. Doesn't it look like a polynomial in the numerator and a polynomial in the denominator, a p of x divided by a q of x, whatever that may be? Okay, now, someone who isn't in Algebra 2, maybe you're just learning about stuff in Algebra 1, you might jump the gun and think that you could start canceling, right? Like some people might want to cancel the x squared and the x squared or something like that. Not allowed. Are these things in the numerator and the things in the denominator being multiplied? No. So like x squared, 5x, and 6 are not factors. They're what we would call terms. Terms are things that are being added or subtracted. So you as an Algebra 2 student need to be on the lookout for this. You cannot just cancel terms, things that are separated by plus or minus. You can only cancel things that are factors. So if we have something that looks like x squared plus 5x plus 6, that's called a trinomial because it has 3 terms. Is there a way for you to find factors? No, we're not going to do polynomial division. Is that what you're thinking about, like what we did last week? No, we're not going to divide. But just like focus on your numerator. X squared plus 5x plus 6. That's a trinomial. There are 3 terms. We're going to factor it. So make sure you know how to factor. if we've got a 1x squared here, this makes for an easy factoring, right? Do you have factors of 6 that add to make 5? 1 and 5 are factors of 5 that add to make 6. 2 and 3. So we'll say x plus 2 and x plus 3. Now, side note, you guys are all going on in math. You have to be factor professionals, factor masters. If you're not feeling confident in your factoring skills, you do that summer packet this summer, you better be on it for factoring next year. It will make everything so much more enjoyable if you know how to factor. Because if you're stuck on factoring, it's just really frustrating. I also want to point out that at this point, I would think everybody should be able to take a eyeball moment and just verify that that this will multiply back out to be the thing that you said. So that's really easy for me. I'm not even going to write it down. I'm just going to check it. First terms, x times x would give me x squared. Last terms, 2 times 3 would give me 6. And then to check my middle term of 5x, I just use my fingers. I'm going to do the outsides and the insides. 3x, 2x. Does that give me 5x? Yeah. That literally takes me 3 seconds, but it can be so helpful so that you don't make a factor mistake. Okay, moving along, what can you factor in the denominator? X cubed plus 2x squared. You could take out an x squared. They both have x squared. They both have x times x in them. So we can take out an x squared, and then we're left with x plus 2. Now, notice, instead of having things that are being added or subtracted in the numerator and the denominator, which would be terms, not factors, now we have things that are being multiplied in the numerator and denominator, so now we have factors. Things that are being multiplied. Well, what do you notice? X plus 2 in the numerator cancels with x plus 2 in the denominator. And your answer is x plus 3 over x squared. Okay. Don't get cancel happy and start canceling those x's again, right? That x in the numerator is now a term, something that's being added with 3. So I can't cancel x and x squared. Okay. So basically, here's what you just did in order to be able to simplify a rational expression in Algebra 2. There's basically 2 steps. Number 1, factor everything. Factor every numerator, factor every denominator. Make sure it's completely factored. Sometimes you factor and you can factor again. And then step 2, cancel out the common factors in the numerator and the denominator. So I'll give you another one just to try on your own. See if you can simplify x squared minus 81 over 2x minus 18. Okay, as I'm walking around, I'm seeing some really good stuff. Just as a reminder for factoring, this numerator is called a difference of perfect squares. So we have a special factor pattern for that. We use the square roots of x squared and 81, but then they have opposite signs. That way the middle terms, negative 9x and 9x, will cancel out. And then in the denominator, take out that greatest common factor of 2. We're left with x minus 9. Cancel your x minus 9s, and you get x plus 9 over 2. I really don't worry about separating this. So if you wanted to write like plus 4.5, then it would have to be x over 2 plus 4.5. Remember, both terms are being divided by 2. But you can just leave your answer like this. Is it possible for nothing to cancel when you factor everything? Yeah, then that would just mean it was already in its simplest form. That happens to us sometimes with fractions. And then, is it possible for everything to cancel? Yeah. What would be left over if everything canceled? It would be equal to 1. So it wouldn't be equal to 0, it would be equal to 1. Because like something divided by itself is 1.
Is it possible to get back to that form from that?
Yeah, you just multiply both numerator and denominator by x minus 1, or x minus 9. Yep. So multiply by the factor that you canceled.
How would you know that you factored? How would you know that it was canceled?
Well, you wouldn't do that.
Okay, so we're not going to have to.
No, I will not ask you to. Okay, now, let's talk about multiply. Okay, from Algebra 1, oops, sorry. You might see something like this. Let's kind of just have a brainstorm session together. What might you do to simplify or multiply this? What would you do first? X over 5x squared times xz cubed over 18y squared.
So like there's a 1 from the x cubed, so I have to do 3 times 1. 3 over there on the answer side. Now it's x times.
Okay, so Lexi's saying I just multiply across in the numerator and multiply across in the denominator. Sure. Okay. So we'll get 3x squared z cubed. And then in the denominator, 5 times 18 is
50.
90 x squared y squared. Okay. And then after you multiplied, you would simplify, right? Make sure that it's in its simplest form. So the x squareds cancel, and also 3 and 90 share a common factor of 3, so we could reduce them. That would be 1 and 30. So we'll come up with z cubed over 30y squared. Now, you know, we were all like, maybe not all of us have our calculators out, so there was that moment where we had like to do 5 times 18, and we were all kind of like, huh. So like another option besides multiplying across right away would have been to do like a little bit of reducing in the very beginning. So just note, you don't have to multiply it right away. I could look at what's over here and say, well, 3 and 18 share a common factor of 3, so that's 1 and 6. I could also do a little bit of simplifying, like this x will cancel out the square, and then this x will cancel out that x, right? This is really x times x, which would be x squared. And will I get the same answer? Yeah, but it's a little bit easier because my numbers are smaller. So now, what does this look like in Algebra 2 when you're multiplying rational expressions? Looks something like this. Let you write it down. X squared minus 2x all over x squared plus 2x plus 1 times x squared plus 4x plus 3 all over x squared plus 3x. Bless you. And my question to you would be, would we want to multiply across in the numerator and the denominator first here? No way, right? I don't want to distribute all these terms and get some quartic polynomial that I would then have to try and factor, right? So it's probably best if you're being asked to multiply rational functions to do what first? Factor them, right? If you factor these right now as they are smaller and simpler, you'll still see if they share any common factors in the numerator and the denominator. So go ahead and see what you can get factored for me. Thank you.
Boom, roasted.
Retake that one all the way back and not move this one. Can you factor the numerator of the first fraction?
Yes. Oh wait. Numerator?
Yeah. Yeah, how can you factor x squared minus 2x?
Oh, I just turned it cancel.
Takes out on x. Oops. Sorry. Can I do that? Take out an x from both terms. So we got x times x minus 2. Okay, can you factor the denominator?
Yes.
What's x squared plus 2x plus 1? X plus 1, x plus 1. You can also write that if you want as x plus 1 squared. Either way is fine. Okay, numerator?
X plus 3, X plus 1.
X plus 3, x plus 1. And denominator. Take out the x. Okay, tell me what cancels. An x plus 3.
X plus 1.
An x plus 1. And the x. Notice you can cancel it if they're part of the same fraction. And you can cross cancel as well, like I did with like the 3 and the 18, because in the end, aren't we just gonna like multiply across, and they're all gonna be in the numerator and they're all gonna be in the denominator? So you can cancel across. The main thing to remember is, in order for you to be able to cancel, there has to be one factor in the numerator and one factor in the denominator. Never cancel if they're like both in the numerator. Okay, write what's left over. X minus 2 over x plus 1. Simple, right? Yes.
It's crazy how you get all of that coming out of that.
Yes. Okay, so don't get cancel happy. Don't cancel out those x's. Don't say the answer is -2, right? Those are now terms, not factors. Everybody okay so far? All right. So we've done simplifying where we just had one fraction. We just factored the numerator, factored the denominator, canceled stuff out. Now we've just completed multiplication, which, did you really multiply at all? No, not really. Okay. You did multiplication, which is really just the same thing, factor and simplify. So if you want to make a note in your notebook, I don't think you have to rewrite these, but notice this is the same set of steps as simplify. Okay. Factor everything, cancel common factors. Okay. Last thing we want to do today is practice division. So I've got a division problem here. We've got x squared plus 2x minus 35 over x squared minus 7x plus 12 divided by x squared minus 13x plus 40 divided by 3x squared minus 12x. Okay. Take a little trip down memory lane to 3rd or 4th grade when you learn to divide your fractions.
Multiply by the reciprocal.
Ah, yes. What are you really doing when you divide fractions? Multiplying by its reciprocal. Some teachers have like a little keep, change, copy, dot, flip. If any of those things sound familiar to you, okay. You could write that in your notes. I just say what it is, multiply by the reciprocal. So I usually start all my division problems by just changing the second fraction. Okay? The first fraction stays the same. This divide by this fraction turns into multiply by the reciprocal. So I'm just going to cross this off. And I'm going to write times 3x squared minus 12x over x squared minus 13x plus 40. So dividing fractions is really multiplying by the reciprocal. Now you do it. Same thing. Factor and cancel. Right? Yeah. So now we're doing just a multiplication problem like we did before. Factor everything. Let's see. Factors of negative 35 that add to make 2. Negative 5 and 7. Factors of 12 that add to make negative 7.
Minus 3 and minus 4.
Minus 3 and minus 4. Factor 3x squared minus 12x.
3x.
Take out the 3x. So you're left with x minus 4. And then factors of 40 that add to make negative 13.
Negative 8.
Negative 8, negative 5. If you're feeling like, oh, picking up this factoring, I'm feeling a little slow, I'm feeling a little rusty, you'll go online, go coolmath.com, practice their factoring things, not their games. See, you know, get that extra practice that you need. Okay, tell me what things cancel.
X minus 4.
X minus 4? Anything else?
Minus
X minus 5? I think that's it, right?
Yep.
Okay, so in this case, my final answer, I'm going to write what's left over in the numerator. What is that? 3x times x minus 7.
What about x plus 7?
Oh, sorry, plus 7 is what I meant. 3x times x plus 7, all over whatever's in the denominator. That's x minus 3 and x minus 8. And you don't even have to multiply that stuff out. You just leave it alone. That's fine. If you do multiply it out, then I'm going to check to make sure it's all multiplied correctly. And if you have anything wrong, I take off for that. So I say it's better to not even do that extra work because you might make a mistake. Okay. Anybody got any questions for me?
Why?
What?
I said
Why?
why?
Why are we doing this?
No, why don't you want us to multiply out?
Oh, because, like, you could multiply it out 3x squared plus 21x over x squared minus 11x plus 24, but they're the same answer.
Okay.
And it's that whole thing of, if you multiply it out, I'm going to check your answer, and it's got to be right. So why open yourself up to more mistakes?
So this is where, like, on the, if this is on the ACT, would we multiply out?
It would depend on what your answers look like. If your answers look like factors, I would not multiply it out. If your answers look like polynomials, I would multiply it out.
Okay.
You just have to match the answer. Okay. Let's see. Your homework is next. You're going to have some time to work. Probably get most of it done.